Chapter 10 homework questions 3, 4, 7, 8, 9, and 10. Question 3. Regarding the pooled and non-pooled two procedures, what's the difference? The difference is the pooled procedures requires equal population standard deviation, but non-pooled does not. How important is the assumption of independent simple random samples for these procedures? It is essential that the assumption of independence be satisfied. How important is the normality assumption for these procedures? If the sample size is small, the normality assumption is essential for both of them, but if the sample has a large size, then it's less important. Suppose that the variable under consideration is normal distributed on each of the two populations, and you're going to use the independent simple random samples to compare the means. Let's fill in the blank. Unless you are quite sure that we say population standard deviations are equal, then we use non-pooled instead of pooled T procedures. Suppose that independent simple random samples are taken from two populations to compare their means. Further, suppose that the two distributions of the variable under consideration have the same shape. They have the same shape. Do we use non-pooled t-test? Do we use non-pooled t-test? No, because if the two distributions are normal and if they have the same shape, it means that they have equal population standard deviation. So we use pooled t-test if they have equal standard deviation. If the two distributions are not normal, but if still they have the same shape, then we use Mann-Whitney test. Under what conditions would the pooled t-test be preferable to Mann-Whitney test? When the two distributions are normal, and because in this case the pooled t-test is going to be more powerful compared to Mann-Whitney. Question 7. Grip and leg strength. So there is a research study and there's a data for measurements of the right leg strength for male and female. So preliminary data analysis indicate that you can reasonably presume leg strength is normally distributed for both males and females, and the standard deviations are approximately equal. At 5% significance level, the data provide sufficient evidence to conclude that the mean right leg strength of males exceeds that of females, and the means and the standard deviations for the samples are given in here. So what we do is we first set the null hypothesis and the alternative hypothesis. Alpha is going to be 0.05 because it says 5% significance level, and because it's going to be pooled, we use the formula for that. We plug in the numbers in here, and after we do that, we get a critical value after finding all these. We using the table, and we calculate the p-value. The p-value that we calculate, it's not less than alpha. It's not less than 0.05, so we do not reject the null, which means that the data do not provide sufficient evidence to conclude that the mean right leg strength of males exceeds that of females. Same question, but this time you will determine a 90% confidence interval for the difference between the mean right leg strength of males and females. If the confidence level is 90% and alpha is going to be 0.1 and DF is going to be 25, add the numbers and subtract 2. And we use table 4, the t-value at 0.05 with DF 25 is going to be 1.708 and SP is going to be 479.33. And the difference of the means it's going to be 284, and this time we use this formula and plug in the numbers, and we will get an interval which is negative 31.3 to 599.3, It means that we can be 90% confident that the difference between the mean right leg strength of males and females is somewhere between negative 31.3 and 599.3. Or we can see that we can be 90% confident that the mean right leg strength of males is somewhere between 31.3 less than and 599.3 more than of females. Question 9, cotton mouth litter size. There was a research again, and the data in the following table, based on the results of the researcher's study, give the number of young per litter for 24 female cottonmouths in Florida and 44 female cottonmouths in Virginia. For Florida and Virginia. Preliminary data analysis indicate that you can reasonably presume that litter sizes of cottonmouths in both states are approximately normally distributed. At the 1% significance level, the data provide sufficient evidence to conclude that on average number of young per litter of cottonmouths in Florida is less than in Virginia. But this time it says do not assume that the population standard deviations are equal. So we use a different method in here. The means and the standard deviations of the samples are given in here. So because the standard deviations are not equal, we not assume that. We use a different method. Null hypothesis, alternative hypothesis. This is the significance level alpha, which is 0.01. We plug them in the formula, plug all the numbers in the formula, and after we do that, we will get a critical value, and we also calculate the p-value. The p-value we found is going to be less than alpha, the significance level 0.01. So because it's less than that, we reject the null. And we say that the data provides sufficient evidence to conclude that on average, the number of young per litter of cottonmouths in Florida is less than that in Virginia. Question 10, the same question, but this time it says find a 98% confidence interval for the difference between the mean litter sizes of cottonmouths in Florida and Virginia in your results. The confidence level is 98%. Interval is 98%. So alpha is going to be 0.02 and df is again the same as 6 to 5. And if we use the table 4 to get the t-value at 0.01 with df 6 to 5, it's going to be 2.3 to 5. And the difference of the means is going to be negative 2.13. Then we use this formula and plug the numbers in. After we do that, we will get an interval, the end points, which is negative 3.4 to negative 0.9. And it means that we can be 98% confident that the difference between the mean litter size of cottonmouths in Florida and Virginia is somewhere between negative 3.4 and negative 0.9. Or it means that we can be 98% confident that on average cottonmouths in Virginia have somewhere between 0.9 and 30.4 more young per litter than those in Florida.